So 5.3 is now going to talk about inverses. So when we talk about an inverse relation, what that is that is the set of ordered pairs. So the set of ordered pairs obtained by flipping or exchanging. So flipping the x and y coordinates. Okay, so if it's saying find the inverse of the relation, so a relation is a set of numbers. So find the inverse. If our points are 1, 3, 6, 3, 6, 0, and 1, 0, that means that our inverse, according to what the definition says, we've got 1, 2, 3, 4 points, and we just flip them. So 1, 3 becomes 3, 1, 6, 3 becomes 6, or 3, 6, 6, 0 becomes 0, 6, and 1, 0 becomes 0, 1. And those are your points that you have. Now it says if a relation is a function, and our function is typically represented with f of x, and the inverse of that function is itself a function, it's called an inverse function. And the way we represent inverse is f to the negative 1 of x. The inverse of a function may not always be an actual function. So something to keep in mind is that the graphs of f of x, which is our original function, and the inverse, f inverse of x, are reflections of each other. So they are reflections of each other over the line y equals x. So they're reflections of each other over the line y equals x. And there's an algebraic way of determining what an inverse is, and then there's going to be a way of determining whether functions are actually inverses of each other. All right, so step 1, we have to find the inverse, then we're going to graph it, and we're going to graph its inverse. So there are a few steps. There's 4 steps you want to follow when you're trying to find the inverse. So step 1 is you're going to replace f of x with y. So we get y equals 2x minus 5. Step 2 is you're going to switch the x and the y. So switch the x and the y. So instead of it being y equals 2x minus 5, it's now x equals 2y minus 5. Then for step 3, you're going to solve for y. So we're going to add the 5 first, and then you're going to divide by 2. So I'm going to divide every term by 2. So I get y equals 1/2 x plus 5 halves. And then for step 4, you're going to replace y with f inverse of x. So our original function started with f of x, which means our final answer needs to finish in that same format. Okay? And this is your inverse. So we have our function, and then we have our inverse. And now what we're going to do is we're going to sketch them. So our inverse is 2x minus 5. So that means 1, 2, 3, 4, 5, up 2 over 1, up 2 over 1, up 2 over 1. Let me try to draw as straight a line as possible. For our inverse, we go 5 halves, so that's between like 2.5. And then I go up 1 over 2, up 1 over 2, down 1 to the left 2. And again, I try to draw the straightest line that I can. Now, up above, it had said that the inverse and the function should be symmetrical about the line y equals x. So that is your y equals x. And if you look, this is your original, so this is f of x. And then the blue one is your inverse. If we were to flip the green over the red line, they would in fact match up for those two. So that's just showing you how they're inverses. All right, let's try another one. All right, so let's follow our steps. So step 1, we change f of x to y. Step 2, we switch the x and the y. Step 3, we have to solve now for y. So we have x plus 1 equals 1/2 2y squared. Then I'm going to multiply both sides by 2. So I get 2x plus 2 equals y squared. And then I'm going to take the square root. Now remember, when you take the square root, you're going to end up with plus or minus. And then step 4, just make sure it's f of x. You got to rewrite it f inverse of x. And then you get plus or minus radical 2x plus 2. And then don't worry about graphing. So I'll just write, don't worry about graphing. This one, because we haven't done everything there yet. Okay, so the next thing we're going to do is we are going to determine whether functions, two functions now. So you're given two functions, and it says two functions, f and g, well, they're inverses of each other if and only if their compositions are the identity y is equal to x. So if we're given the two functions, if we get the identity when we do the composition of functions, what that means is they are in fact inverses of each other. So what you have to do is you have to check that f of g of x equals x and g of f of x is equal to x for them to be inverses. And that's what we're going to do with the last 3 problems here. So if we're determining whether they're inverses, I'm going to do f of g of x. So now g is going to go in place of the x in the f of x function. Those cancel, but I'm distributing to both. So I end up with 24 over 4, which gets me 6. Or sorry, that's a 1. So I get an x, my bad. Then I get plus 6 minus 6. The 6's cancel, and I end up with x. For g of f of x, same idea, but now the f goes in place of the x in the g of x function. Plus 8. So again, that becomes an x. Minus 8 plus 8. The 8's go away, and you're left with x. So they both equal x. So yes, inverses. And if you ever had to say explain, you would say because f of g of x equals g of f of x, which equals x. It can only equal the identity. It cannot equal anything else. All right, so I would pause and try these last 2. See if you can get it while I do them myself. And then come back and double check. So you should be finding for B that they're not inverses. And again, if you have to explain, you just say f of g of x does not equal g of f of x, which does not equal x. So same explanation, it's just yes it does or no it doesn't. All right, last one here, f of g of x. So subbing this guy in, when I square, I get 4 times 1/4 times x, and I get x, so that's good.